Okay. How did balancing go? The numbers 1 through 5? Yeah, they were okay. Were they okay, or would we like to go over any of them? Number 5, I figured. Yeah, number 5 is a little tricky. Yes? So most balancing is really straightforward. This is an example of one that is not as straightforward. So let's start by writing out how many phosphorus, oxygen, and hydrogen we have on each side. 4 phosphorus. Now you have to watch out for this one because we have 10 and we have 11 oxygens, okay? So we have 11 oxygens, and hydrogens we have 2. On the right-hand side, we have 3 hydrogen, 4 oxygen, and 1 phosphorus. So this one maybe requires like a little bit of, sometimes balancing is a little bit of just playing around with things until it balances. But you got to believe that unless we are dealing with combustion, your numbers are never going to be ginormous. Okay, they're going to be like under 10. You know what I mean? Like 10 and under, unless we're doing combustion. So I'm looking here, and we were doing even and odd. We have a whole bunch of different even odd things, yes? So I'm looking at this and I'm saying, over on my left-hand side, I have 4 phosphorus, and on the right-hand side, I have 1 phosphorus. I'm just going to do that one first, just randomly. And when I put the coefficient in, okay, then I need to update everything that needs updating. So I'm going to update my phosphorus because now I have 4 times 1 is 4 phosphorus. Oxygen, I have 4 times 4 is 16 oxygen. And I have 3 times 4 is 12 hydrogen. Okay. Now, the oxygen is looking a little icky, so I'm going to try and balance the hydrogen and just hope that everything else works out, because often that will happen. So let's see if I can just balance my hydrogen and make it all be okay. So if I need to balance my hydrogen, I have 12 on the right. What coefficient do I need here to have 12 on the left? I need a 6. Okay, so I put in the coefficient, then I update my little chart. So 2 times 6 is 12. And my oxygen, now I have 6 times 1. Okay, I have plus another 10. So now I have 16. And oh, wow, look at that. Yeah? Now, I happen to luck into a good choice. By doing phosphorus and then oxygen and then hydrogen and then oxygen, it worked out nicely. Shall we try it another way just to see? Okay, I'm just going to backtrack here to the beginning numbers. Okay, so let's try balancing our oxygen first. Ooh, that sounds, oh, you know what? I would not balance oxygen first just because it's in 3 different places, and that sounds really complicated to me. I'd be like, ooh, that sounds icky. So let's try balancing hydrogen. Okay, so if I want hydrogen to balance, I could put 2 as a coefficient here. That will give me 6 hydrogens. Okay, 2 times 3 is 6. that will update me to 2 times 1 is 2 phosphorus, and 2 times 4 is 8 oxygen. How did I choose to put a 2 here? Well, I looked at that 3 and I looked at that 2 and I said the lowest common multiple of 3 and 2 is 6. So I want to multiply 2 times 3 to give me 6, and over here I'll multiply by 3. So 3 times 2 gives me 6 hydrogen, and now I have 10 oxygen plus another 3 oxygen gives me 13 oxygen. And again, I might say to myself, oxygen looks really difficult to balance because there's so many things there. So I might then choose to say, what if I were to balance the phosphorus now? What would I have to do to balance phosphorus? I have 2 on the right and 4 on the left. I would have to change my coefficient, yes? From a 2 into a 4. I'm going to update my chart once again. I'm going to do it in blue this time. 4 times 3 is 12. 4 times 1 is, oh, did the wrong place, so sorry. 4 times 1 is 12, that's hydrogens. 4 times 1 is 4 phosphorus. And 4 times 4 is 16 oxygens. All right. And then remember I said oxygen continues to look icky, so I'm going to keep staying away from oxygen just because it makes my head hurt a little bit. And if I do that, I say, oh, I have 12 hydrogen now and I only have 6 over here. So instead of having a 3, I would need to change this to a 6, which would then give me 12 hydrogen, which would update that to 6 and would update that to 16. So by kind of avoiding the nastiest element, the one that seems hardest to balance because it's all over the place, I make my life easier for myself. Okay, I could do it with oxygen, but it just makes your life more challenging. Yeah? Okay, so we've got our even and odd strategy, use the lowest common multiple. Here's another strategy that will work. This works best for synthesis, decomposition, and single replacement. If you've got some elements and a compound, put the coefficient on the compound first. So over on the right-hand side, I can look and I can say, I'm going to put a coefficient on the K2O. And if I do that, what coefficient might I like to put on the K2O that would balance something? I'd like to put a 2 here because that will balance at least the oxygen. Yes? So there's a 2, and now the oxygen is 2, but the K has become 4. Okay? And now I have 4 Ks, and I can just put a 4 in front of my K, and that gives me 4 Ks here. Okay, you could also have done the even odd thing here where it's like, oh, I have an odd number of oxygen on the right, so multiply by 2, that's going to give you an even number of oxygen. Okay. So give these ones a try. Okay, 6, 7, and 8. Balance them. Would it be better if I put like AG and O in here? Should I update the workbook with like this? Yes. Okay, I will do that for next year. Okay. Yeah. Yes. If you end up, folks, if you end up with something that can be simplified, like all of your coefficients are divisible by 2, you should simplify it. Okay? Yes. One is not divisible by 2. Ah. Oh no, that's no. Just sometimes people will balance things and they'll end up going too far, and they'll end up with 2, 4, 6 instead of 1. Right. Yeah. Oh, who needs a reaction types sheet? Who's been away and did not get one of these lovely creatures? Anyone else? Not get a reaction type sheet? You got one? And another side as well. Which side makes sense? Yeah. 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 Yep. Okay. Okay, so let's all check our answers here. What did you guys get for the first one? Well, we need to have 8 sulfurs, yes? So we put that 8 on that sulfur there, which gives us 8 times 2 is 16. So we need 8 here as well, okay? I'm just double checking, so I'm not making the chart. Feel free to keep making the chart. Let's see. I've got 2 O's and only 1 O, so I'm going to put a 2 here. All right, and then we have 4 AGs, so that's a 4. Now, when I say simplify, can I simplify that one? Is it possible to simplify that one? It looks a little bit like it, except that, what's the number here? It's a 1. Now, just for future reference, if you have blanks in front, you can write the number 1 if you want to. But if you're writing it without a blank, like if you're just answering it free form, you should not use the coefficient 1. It is assumed. It's like we don't write CO2 as C1O2. We just don't write those 1s. It's the same for reactions. If you want to write the 1, if there's a blank there, if it helps you keep track, that's fine. But normally we don't write the 1. And then finally, down here, we have, let's see, we got 2 hydrogen here. So that's 2 hydrogen, 2 fluorine, 2 sodium. Okay. What type of reactions are these? What type of reaction is S8 plus O2 gives SO2? Everybody, that is synthesis. 2 things become 1, synthesis. This one, I would not expect you to be able to predict the products because you don't necessarily know how nonmetals combine, okay? So that one I wouldn't expect you to be able to predict. Ag2O goes to Ag plus O2. What type of reaction is that? That is decomposition, DEC. Could you have predicted those products? Right? You only have one reactant and you say, I only have one reactant, that must be decomposition. What can it do but break down? There's nothing to switch with, there's nothing to react with. All it can do is break down. And you know that silver does not have a subscript, and you know that oxygen is diatomic, so it's O2. Okay? What's our last type here? Single replacement.
Metal.
And it is a metal. Now, it's interesting because hydrogen is technically a nonmetal, but sometimes hydrogen behaves like a metal in that it is H+. If you see hydrogen at the beginning of a compound, it has a positive charge. Okay. Yes, in acids, hydrogen always has a +1 charge. Okay, this is going to be a really good strategy, this next one. Deal with atoms in the most complicated compound first. And this works really well for double replacement and neutralization. Now, what the heck is the most complicated compound? It is the one with the highest total of the subscripts. So you just kind of look at it and you go, who's got lots of subscripts, and are those subscripts big? So if we look at this particular equation here, could you choose who is the most complicated based on these subscripts? Iron 3 sulfide, the Fe2S3. Yes, it's got 2 different subscripts and it's just the most complicated. So we're going to work on balancing that first. We're going to leave it alone. Okay. So what we're going to do is we're going to leave the Fe2S alone, and we're going to first deal with this little 2 here. Okay. And so we're going to put a 2 in front of the FeCl3. That gives us now 2 irons, and 2 times 3 is 6 chlorides. Second thing we're going to do is we're still going to go back to our most complicated. And we're going to say, now I need to balance the other one. That's our S3. What coefficient would I need to put where to get 3 S's? 3 in front of the Na2S, absolutely. Okay, so now that changes our sulfur becomes 3, and our sodium becomes 3 times 2 is 6. And generally what will happen is that you'll look at it and you'll say, the iron is now okay, the sulfur is now okay. All I need to fix is the sodium and the chloride. Can I fix them by putting a coefficient on one of the products?
Yes.
Yes. And you'll just need one coefficient and it will fix both of them. Okay? And that'll give you a 6 and a 6. So double replacement How do you know you have a double replacement reaction? What are the two reactants? What types of things are they? What types of chemical species? I'll give you a choice. There's elements and there are compounds. In a double replacement, you have a compound plus a compound. Not that that's the only compound plus compound. That's supposed to be a D. And so you can say, oh, if I have double replacement, I'm going to look for that most complicated formula and balance those ones first. Could you guys please give, oh, hang on. There's just one example. Strategy 5. We're going to do strategy 5. Because here we have one that's a compound and a compound. We are going to utilize strategy 4, which is balance the most complicated one first. Who is the most complicated compound here? NaZN4, because the 4 is really big. So how many NAs do we have on the right-hand side? We have 2. But remember, we're learning a new one as well. We're going to balance our lone elements last. Who is a lone element here? Na. It's on its own. So when we say lone, we mean it is alone. So we're going to balance Na last. So we're not going to worry about the Na. We're only going to worry about the zinc. So zinc is at 4 on the right. Let's make it 4 on the left by putting a coefficient here. That means now we have 4 zinc. How many iodine do we have now?
8.
We have 8. 4 times 2 is 8. And remember, who are we balancing last? Na, because it's on its own. Because what it means is you can balance it without mucking up anybody else. Okay? So now let's balance I. Okay, we have 8 on the left. We need to have 8 on the right. So a coefficient of 8 can go in front of NaI. That gives us 8. Ooh, not 8, but 8 plus 1. How many how many NAs? 9 NAs. Oh, I wrote it the wrong place, didn't I? 9 NAs. And iodine are only in that compound, so there are 8 iodines. So iodine is okay now. That's good. Zinc is okay, and the only thing left for me to balance is sodium. And because it is on its own here, all I have to do is throw a 9 on front of that, and I haven't mucked up anything else. So by leaving it to the end, it just makes it a little easier. Okay? All right, I would like you to try numbers 9 through 12 on page 32. They're just going to be there to muck with you a little bit. You will hardly ever see reactions that look like that. They're mainly there as a balancing exercise. Do you know what I mean? Like, what the heck is a KCD7? That's not a real, like, yeah. Yeah. Did you start by balancing things well first? Getting balance. Oh, that's gonna make your life easier. So you're gonna balance the molybdenum and the graphene. That'll make your life easier. Okay. Maybe there's one there, so we. Right? Well, you can write in the one here. To help you with it. Then you go. Oh, no, you can, that's not. I know, and it feels like Friday when we say like that. Okay. Absolutely. Smart. What I'm gonna say is, I don't think we want to not show up. No, I substituted for one day and basically for the year around the hospital. And I was like, start my balancing most complicated in the first year and start with different MOs and 5 and Folks, I'm just gonna do that first one because a lot of people are kind of didn't quite catch the strategy of do the most complex compound first. So let's take a look. So what I do is I say, who is most complicated? That is the MO. N5. I've got lots of coefficients there, so this is the most complicated. So what I'm going to do now is try and get 3 MOs on the other side and 5 Ns on the other side. So I'm just going to put a 3 in front here to give me 3 MOs, and I'm going to put a 5 in front here to give me 5 Ns. Once you get that far, list out your elements if you haven't already done so. So we have 3 MOs, 5 Ns, 1 Na, and 1 Br. Now we have 3 MOs and 5 Ns. And then how many NAs do we have? 5 times 3 is 15. How many BRs do we have? 5 times 3 is 15. So if you do it this way, if you say, here's my most complicated thing, put those coefficients that make the 3 MOs and that make the 5 Ns, then your last balancing step will just be to say, oh, I need to stick a 15 in front of this that will fix both of those at once. Okay, so if you had trouble with that one, you're going to start with Fe 3O4, and you're going to try and get 3 Fes and 4 Os on this side and go from there. Okay? That helped. Good. Just one thing. It's just a group. It's like one pencil case includes 2 pens, right? And an eraser, right? But you're just gonna balance pencil cases. You can balance. Not be expected to poly and non-violent and grade as a group. Yeah. Yeah. You pretend it's a single atom. You pretend it is. Okay. Yeah.
So it's again, it's a multi.
Yeah. Yeah. And it makes it really easy to balance it here. Yes. So yeah, you're gonna say, I'm gonna belt my. So I would start with the workations. Yeah, yeah. And now, I would say, let's do some 2 places here, which means I'm gonna leave those until we have to. Oh, okay. No, I can now take a look at my, I'm gonna say my. Okay, yes. We'll share. Right. Yeah. So. Yeah.
So I want to.
Yes. Yes. So if you see one, you got like 2 compounds that you paint.
Yeah, the scenarios first.
Yes. Are there any of those that you would like me to go over?
Yeah.
Okay. For this one here with the lithium and the hydrogen, it's a weird reaction. I mean, to be frank, you're never going to come across reactions like this in the wild. Okay, this is like a made up, let's make balancing challenging for you reaction. Okay, so again, you can say my most complicated thing is the hydrogen. So I'm starting on the left-hand side with 1 lithium, 1 hydrogen, 1 aluminum, and 3 Cls. Over on the right-hand side, I have 1 lithium, 4 hydrogen, 1 aluminum, and 1 Cl. This has the biggest subscript, so let's fix our hydrogens. We'll put a 4 in front of the LiH. That gives us 4 Li's and 4 H's. This pen will drive me bananas. That's okay. All right. I don't like the look of this lithium because it's in 2 places. on the product side. That makes it hard to balance. So I'm going to leave lithium alone and hope that it works out in the process. So we're just going to leave lithium alone, and let's deal with something that looks a lot less complicated, like the chlorine, because I've only got chlorine in one place and one place as opposed to the lithium, which is 3 different places. So I could balance the chlorine by adding a 3 here, which would give me 3 chlorides. That now gives me 3 lithium plus 1 lithium is 4 lithium. And oh, look, the lithium did work out in the end. So just stay away from those complicated ones where it's appearing in 3 different places, because it can just, you can work it out with the other elements. All right. Strategy number 6. This is now on page 33. A polyatomic ion is going to be treated as a single unit. Okay? So what that means is that if I have if this is a polyatomic ion, it contains a pen and a cap. This is the pen atom, this is the cap atom. But I have one of the entire thing. I can balance it if I have pens and caps together on the other side. I can balance them as a unit. I don't have to say I have 1 cap and 1 pen, and on the other side I have 1 cap and 1 pen. I can say I have a pen cap. Yes, pen with cap. And that's like, say, an OH ion, a hydroxide ion. All right, so we treat them as a single unit, as one thing. So when we're making our little chart here, we can look and we can say, okay, here is, we've got lead. We have NO3, which is a polyatomic ion, and you'll notice it remains NO3 on both sides. If NO3 were to change into something else like NO2, you could not use this technique. It has to stay the same from both sides, okay? I couldn't have, if I had this on the opposite sides, it's not the same thing, and I can't balance it as a unit, okay? And then we have our Na and we have our I. Once again, you're going to balance, hopefully, your most complicated things first. There's not a lot to choose between. The only thing I'd like you to take notice of, how many NO3s are there here on this right-hand side? How many NO3s? Just 1. If you have, there's not 3. If there were more than 1, you would have brackets and the 3 would be on the outside. Okay, so we've got 1 NO3. So I don't know that it really matters. I'm just going to choose this one. I'm going to balance my NO3 first, because why not? I've got 2 on the left. So we can put 2 in front of the NO3 compound. Gives us 2 NO3s, and that changes Na to 2. Lead is good. Nitrate is good. NaI is not good, but if I put a 2 in front on the right, on the left-hand side, sorry, that fixes both of them. Okay? Here's a little bit more complicated one, just a little further down the page. We have whole tons of things. Can you point out to your neighbor the polyatomic ions? We have ClO3 is one of them. Who's the other one? CO3. So we have ClO3 and we have CO3. So if we make our little chart, we look at our irons, we have 1 on the left. Chlorate, we have 3 on the left. Potassium 2, carbonate 1. And remember, this 3 does not mean 3 carbonates. It just means there are 3 O's in a CO3 ion. Okay. Who's the most complicated compound here? Is it 1, 2, 3, or 4? Who is most complicated? 3. 3 is most complicated. So what we're going to do is we're going to say the first things that I want to balance are the iron and the CO3. And we're going to do that by putting coefficients on the other side. So we have 2 iron. So let's put a 2 in front of the iron. And we have 3 carbonate, and there's no coefficient, there's no subscripts here, so we'll put a 3 here. And now we'll update all our numbers in our chart. Iron, we now have 2. Chlorate, we now have 2 times 3 is 6. Potassium, we have 3 times 2 is 6. And carbonate, we have 3. On the right-hand side, well, carbonate is good and iron is good because we just balanced that complicated compound. And now to fix potassium and chlorate, I just need 1 coefficient. That's going to be a 6 in front of the K, ClO3, and we're done. Is good? So when you have polyatomic ions, treat them as groups. And it's done for you for the first little while. It's like, oh yes, let's make sure that we have our polyatomic ions. So please try numbers 13 through 15. And don't be shy about working ahead if you're bored, okay? So these exercises are on page 34. Pages 34, 35. Good. Yeah, exactly.
Yeah, they left all those changes. Slacking back and forth. They kind of sat there. It's kind of such a reason. Yeah, but it makes no sense. Yeah. Why? Hit my dad. And like, like, it's not going well. No, it's like, oh, yeah. Sorry, okay, do you know what? I have another dusty guy. Okay. Like that. Well, thanks. All of this?
I didn't get one.
It's stole our rock from our mouth. Right? Yeah. The one, yeah. All right. You have nothing down here. You must be done already. Maybe this was necessary. Oh, wait, say. Yeah. Yeah. Shot him. I would just do like. Yeah. Oh, these guys are all from Texas. You all. Oh my god. Like I all. Yeah. Next one, do you how much you don't build a child, you know, each child of lawyers a day. Look back from Vegas, Russell, kind of funny.
This is just really damage.
Okay, on page 35, we have strategy number 7. And that is that water, H2O, can be thought of as being made up of an H plus ion and an OH minus ion combined together. So if you have on one side of the reaction a hydroxide ion, wouldn't it be nice if you had a hydroxide ion on the other side to balance as a group? So what you can do is you can rewrite water as H, OH, and now you have hydroxide on the other side. So this works really well for single replacement if water is involved. It also works really well for neutralization. Those are going to be things where you've got those OH on one side. So let's take a look at this one here and see if we can balance it. So if I have Li, and I'm going to make my OH red here so that you can see it a little bit better. There's our OH, and here on this side we have an OH. At this point in time, everything is balanced except for the hydrogen. So let's balance the hydrogen. We have 2 on the right, so let's put 2 on, no, putting in the wrong place, sorry. Let's put a 2 on the left. That gives us 2 hydrogens. And it gives us 2 hydroxides. Now the lithium is balanced, the hydrogen is balanced. We can balance the hydroxide by putting a 2 in front of the LiOH. So now OH becomes 2, but it unbalances the lithium. But that's okay because lithium is on its own over on the left-hand side. So we put a 2 here, and now everybody is balanced. Okay? Here's another one. We have H2CO3. So let's pick out our polyatomic ions first. We have CO3 and we have CO3. If you see an OH on one side and you see water on the other side, remember you can rewrite the water as H, OH, and then treat the hydrogen separately. Okay, so now we have our OH and our hydrogen are being treated separately. So once again, you can use your technique and say, who is the most complicated compound here? Who's most complicated? Fe2CO3. 3. We got lots of little subscripts there. That's a very complicated looking compound. So we're going to balance iron and carbonate. So to balance iron, we need to put a 2. And to balance carbonate, we need to put a 3. And now we're going to go and update our chart. 3 times 2 is 6 hydrogen. There's only 1 carbonate here, so 3 times 1 is 3 carbonates. We have 2 Fe's, and we have 2 times 3 is 6 OHs. So you'll notice now that our iron and our carbonate are good, and the only thing missing is the H's and the OH, and we need 6 of each. So if I put a 6 there, that gives 6 hydrogen and 6 hydroxide. Is good? Okay. So numbers 16 through 21. If you don't like it, you don't have to do it. It's just a technique. If it does not help you, you are not required to use any of these. So once you are done this, your homework will be to complete anything in this section that you haven't done, plus Hebden. Pages 110 and 111. Number 7 through 20. Now, what I'm going to do with that is I'm going to take a screenshot of it and I'll stick it in the homework as well in case you're like, I don't remember how to find Hebden. But if you forget how to find Hebden, it is in Teams, in the general channel, in our files. Maybe I'll even just throw the file up on Teams. You can see it says, oh, that's Chemistry 12, but we'll have one as well. Chem 11, general channel, files. Where's Hebden? Hebden Chemistry 11. And there's a Hebden Chemistry 11 answer key also.
I think I tried it. I actually did. I actually don't know where your phone went. No, it's actually. I go, that's better like this.